Okay, we found that the concentration between 5% to 15%, it's about 0.2216. Okay, the probability is 0.2216 or 22.16%. Okay, now for the third question, okay, find another similar jet. The mean concentration is 18%, so the mu is 18%, so 0.18, and then the standard deviation is given by 5%. Okay, it's given as 5%. Okay, so find the probability that in at least one of the jets the concentration is between 5% and 15%. Okay, at least one of the jets the concentration is between 5% and 15%. So if I label this as jet B, okay, jet B, that's what I've got to find. So therefore jet A, which we already have, okay, which already have is 0.2216. so now jet B, okay, the second info, what is the concentration that we're going to look at? Okay, what is the concentration? So from there, I mean, we have to find what is the percentage for this. Okay, what is the probability for this? Once we have got the probability for jet B, okay, which is with the new mean and standard deviation, then from there we can find what is the probability for at least one, okay, jet between probability for at least one between 5% to 15% concentration. Okay, so first of all, let's find out what is the probability for jet B between for the concentration between 5% to 15%. So same method like what we did for jet A. Okay, same method. Okay, this time, okay, let's draw the bell curve. So the bell curve is somewhat like that. Okay, not so accurate. Okay, if I draw, so again it's between 15%, 5 to 15%. Okay, 5 to 15%. So 15% is somewhere here, so 0.15, and 5% I can say it's somewhere here. Okay, it's just a rough sketch. Okay, don't have to be exact. Okay, just a rough sketch. So that's the area that we are looking at, and mu is already, we know mu is exactly in the middle, which is 0.18, and then the standard deviation is 0.05. Okay, so let's find out what is the concentration over here. Okay, percentage concentration over here. Okay, first of all, 0.05. Okay, so 0.05, let's look at the z-score. 0.05 minus 0.18 and divide this by 0.05, which is the standard deviation, and I'm getting the answer exactly negative 2.6. okay, exactly negative 2.6. so 2.6 is negative, so look at what is the phi of positive 2.6. okay, so phi of 2.6 is, let's look at 2.6, it's 0.9953, and since I'm using the MF19, okay, MF19 is the area towards the left of the value, okay, or z-score, to the left of z-score. So 2.6, 0.9953 will be the huge area over here. But since this is symmetric, okay, normal distribution is symmetrical distribution, so 0.55 basically the area covers, I can switch that, and the area that it covers is on the right hand side. Okay, it's the same thing because it's symmetrical, so it's still the same thing. Okay, 0.9953. now let's find out what is the area for z-score for 0.15. So let's find out the z-score. 0.15 minus 0.18, and then divide this by 0.05, and using your calculator you should get the answer as, okay, it is 0.6. okay, the answer is 0.6. okay, I think this is, yeah, okay, so okay, negative 0.6. okay, again, negative is just on the left side. okay, we can change it positive by looking at the area, but that covers 0.6. so if you look at the positive phi of positive 0.6, you're getting the area as 7257, 0.7257. okay, 0.7257. so 0.7257. so now 7257 is the area towards the left. okay, so towards the left, so basically this little area over here. okay, so I'll redraw. okay, so this little area, okay, exactly from the table. okay, exactly from the table. So to find out what is the area that covers between this is part 1, which is for 9953. this is part 2, okay, area towards left, okay, for 9952. so the area that coincide, so the first one minus the second one, 0.9953 minus 0.7257, and the answer is 0.2696. now the question here, find the probability that in at least one of the jets the concentration is between 5% and 15%. one of the jets. okay, so to find the concentration for at least one of the jets, what I can do is I can 1 minus the probability of no jets. okay, for x0, no jets. The question says at least one, but if I minus 1 minus the probability of no jet is within the concentration of 5 to 15%, then that's the answer for at least one. okay, I hope you get this. okay, so same approach. okay, let's find out for jet A. okay, probability outside the limit 5% to 15%, outside the limit of 5%, because within 5 and 15% we already have 0.2216. so outside this region or this concentration 5% to 15% will be 1 minus this, which is 0.7784. okay, that's for jet A. so again, let's find out for jet B. okay, for jet B, between the 5% to 15% outside. okay, outside this region. okay, so the answer for outside for this region, so again, outside this region. so inside this, within this region, we just got that, which is 0.2696. okay, that is the concentration for jet B. okay, for jet B, 0.2696. so outside this concentration, what I have to do, I have to again minus that. okay, minus this. Oops. Jet B. so to find out 1 minus 0.2696 will give me the area outside, or the probability for outside 5% to 15%. okay, the outside. so when I subtract that, I'm getting 0.7304. so 0.7784 0.7784 is outside the region. okay, outside the concentration, okay, number probability outside the concentration of 5% to 15% for jet A, and 0.7304 is the concentration for jet B outside the concentration 5% to 15%. So I hope you guys can get this. So if I multiply these two, 0.7784 multiplied by 0.7304, I'm getting 0.56854. This is the probability for everything, all both jets, okay, jet A and jet B, outside the concentration of 5% to 15%. Okay, so this is the probability. So what is at least one within 5% to 15%? Yes, 1 minus 0.56854, and the answer is 0.43146.